We can also calculate the volume without actually measuring it using a graduated cylinder. Here we have a styrofoam block, and by this time students will likely have already calculated the volume of a rectangular solid. And we need for that the dimensions of length, width, and height. And so we can measure that using our ruler. So in this case, the length is 20.5 centimeters. The width is 10.3 centimeters, and the height is 4.0 centimeters. Volume of a rectangular solid is given by length times width times height. The length is 20.5 centimeters. The width was 10.3 centimeters, and the height was 4.0 centimeters. The 845 cubic centimeters. We can then determine the mass of the object on the balance, 12.4 grams. So the density is in mass divided by volume is 12.4 grams divided by 845 cubic centimeters with 0.015 grams per cubic centimeter. And you can see that the density of styrofoam then is much, much lower than the density of water or methanol. And so we say that an object such as styrofoam is very light. What we really mean is not that it's light, but that it has a very low density. It has very little matter per unit volume. Also notice that the unit volume is different here. Earlier we had milliliters, and now we've got cubic centimeters. And actually 1 cubic centimeter is equal to 1 milliliter. So we're really dealing with the same volume of matter in both cases. Again, you can use different sizes of styrofoam. Here's a larger piece, and students can again calculate the density of that. Here we have some different type of styrofoam. It may have a slightly different density, and again you can bring in different sizes and have the students calculate the volume and measure the mass, and based on that information determine what the density of the different styrofoam samples are. We can also bring in various shapes. In this case, I have some spheres. And again, we can use a formula to calculate the volume of a sphere. But in order to do that, we need to have, first of all, the radius of the sphere. And one way of measuring the radius is with an inexpensive caliper. This is a plastic caliper available in, I believe, dollar stores, and you can then determine the diameter of the sphere with this, and the diameter of this is then it's about 5.8 centimeters. So we can then calculate its density using mass and the volume. The volume of a sphere that we can calculate is given by the formula V equals 4/3 pi r cubed. So this gives students an opportunity of using the formula so they can calculate the radius from the diameter. So radius is half the diameter. You can also take various cylindrical objects. So here I've taken a piece of wooden dowel. You could also use just a section of a broom handle, for example, or any kind of round object. Or you can also take a candle, such as I have here, and just cut the tip off so that you have a nice cylinder. And students can then measure the diameter using a caliper. They can measure the length of the cylinder and then calculate the volume using the formula for a cylinder. It's the area, which is pi r squared, times the height. So essentially you calculate the area of the cylinder, either one, and multiply that times the height to determine the volume of the cylinder. And you have the balance available to then determine the mass, and so you can calculate the volume and mass, and from that the density. And again, you'll determine that the density of each substance is a unique value, regardless of the size that the object